Right, we're here again. What I'm going to do is I'm actually going to do a very short input on how the encoders work, purely so that you can get an idea of what they can do as opposed to a joystick, and how they work in comparison, but the software would have to be quite different. So we've got an encoder here, which is one of the ones that I showed you the other day. And what I've done is blue peated it for speed. I've got red and black power, and then there's two outputs on an encoder. That third one's a switch, just like we had with the orange one, and when you press the switch on the joystick, it made the button switch, and we'll be able to use that the same way. But what happens with an encoder, when you twist that, what it does is it creates a signal. So if we actually go and have a look at the actual oscilloscope, what I've done is I've slowed that oscilloscope down so it is extremely slow, and what you can do is you can actually, if I twist the encoder now, you can actually see it's making spikes, and you can actually see those spikes in real time. And the red line is one encoder and the yellow line is the other. Now then, what I will do is I will try to do two things at once. I'll actually set that encoding and then stop it. If you actually look at the actual wavefronts, the yellow is behind the red, and that's because I was twisting it clockwise. If I now start that running again, and I twist it the other way, oops, I'll have to do it and then make sure it runs stops. I'll try and do it a bit slower so we can see it better. If you notice now, the yellow is in front of the red, and that's how you know the difference between which way it's been twisted. Because, I'll put it back on run, the wavefront clockwise is the red's in front, anti-clockwise, the yellow's in front, and so you can very quickly tell which way the actual encoder's running. And all I'm doing is literally twisting that probably about half a turn, and so if we go back and have a look, in half a turn we're probably getting about 15-20 spikes. So if that was click 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 click, if you were jog shuttling with that, as you can see, you could actually control that quite nicely to a frame. And bear in mind that the processors are running a lot faster than our eyes. They can actually see that wavefront to come in, they can wait for it to come, and a bit like a buttonhole, we'd have to wait for it to drop off before we could wait and start looking for the next one. But that's literally how difficult encoders are. All you need now is you'd have two digital inputs and a piece of software that's running around, monitoring both those pins simultaneously and deciding, is it going clockwise, anti-clockwise, and whichever way it's going, then we decide whether we're putting one letter in or another. And it ain't much more complex than that, guys.